Welcome back. You've made it to Module 4. In Module 4, we're going to be talking about measuring departmental productivity and the direct costs of delivering instruction. These are important measures for people who oversee academic programs. They tell you a lot about costs and what's happening within a department. This topic is going to be divided into 3 lectures, and in the first one, the most technical of the 3, we're going to be talking about measures of academic productivity. Academic productivity is a term that you should relate to from earlier things in the course. When we were talking about Baumol's cost disease, we talked about increases in productivity. I want you to relate what you learned in that module to this topic, even though it's not a direct relationship. How do you measure productivity? There are technical measures, mathematical measures of productivity, and those are measures of output, generally speaking. So when you think about academic productivity, one of the things you can think about is how many students are you teaching? And you can think about productivity versus efficiency by thinking about the amount of faculty used to teach. What academics typically do is go in depth in a particular topic, and so you can bet when you've got academics who oversee academic programs, you have people who are really boring down into this concept of productivity, and that's what we're going to be doing in the next set of slides. So in this whole section over 3 lectures, we're going to be talking about key measures of productivity. We're going to talk about how instructional costs get measured, what are key metrics of those instructional costs, and what are key ratios. Then we're going to talk about what have we learned through a prolonged study of academic or instructional productivity. And there we're going to talk specifically about something called the Delaware study, which is the longest and largest study to date on productivity. In this first lecture, we're going to focus especially on the key measures of productivity. To do that, we want to talk first about measures of enrollments. The primary measure of instructional productivity when we talk about enrollments is something called student credit hours, and that's abbreviated SCH. You'll see that sort of all over the place. They are often also called credit hours sold. The word sold should not mean that students actually pay for them. They may be credits that students paid for through scholarships. They may be credits that were essentially free to the student, but they are called credit hours sold because they are tied to tuition dollars. To get student credit hours, there's a very simple formula, and that is you take the head count of students in a class, and this is always a measure of class by class or course by course. So you take the head count of students in a class times the credits for that class. So student credit hours equals the number of students times the credit hours for the class. And an example is pretty straightforward. If you have 40 students enrolled in a 3-credit class, you've got 40 times 3 student credit hours, or 120 student credit hours. The idea of student credit hours is a little bit obscure to a lot of people. What exactly does 120 mean, for example, when you're talking about student credit hours? So often, student credit hours get converted to full-time equivalent students. There are a lot of different ways to calculate full-time equivalent students. I think I shared earlier in this course that I once had a 2-hour meeting with a bunch of vice presidents about how we measure what a full-time equivalent something is. And there are at least 4 different ways to calculate full-time equivalent students. But when we're talking about academic productivity, the typical equation is you use student credit hours, and to get a full-time equivalent student, you take student credit hours and you divide that number of student credit hours by the definition of a full-time enrollment for a year. So full-time load for a year. Student credit hours divided by full-time enrollment for a year of enrollment is FTE students, or full-time equivalent students. So let's take an example. We'll make it easy. If you have 1,000 students, each enrolled in an average of 18 credits in a given year. You've got 18,000 student credit hours. Now, what's a full-time load for a student? Well, for a traditional undergraduate, you can define a full-time load as either 30 credits or 32 credits. We'll just use 30 because it ends in 0, and that's easy. So to convert 18,000 student credit hours to FTE students, we take 1,000 students times 18 credit hours divided by 30. That equals 18,000 student credit hours divided by the full-time load for a year, 30 credits. That gives us 600 full-time equivalent students. The math of that, I hope, is fairly straightforward for people. The concept is basically we're trying to get a standard metric that helps us know how many students get taught. We could ask how many students get taught in a year, how many students get taught in a course, how many students get taught in a department. In order to make those kinds of comparisons, you need a very standard metric to be used. And what the FTE student calculation does is it converts, say, courses with different numbers of credits, 2 credit, 1 credit, 3 credit courses. It eliminates those variations because you've got student credit hours calculated. And it converts student credit hours to a number that people just feel like they understand a little bit better, which is FTE students. Student credit hours and full-time equivalent students are variations of exactly the same thing. We say that one is a linear function of the other. And in this graph, I've plotted on the x-axis student credit hours, and on the y-axis converted those to full-time equivalent students. And you can see they fall exactly in a line going up. So if you have 600 student credit hours, that is 20 FTE students. If you've got 3,000 student credit hours, that's the same thing as 100 FTE students. So student credit hours and FTE students are two sides of the same coin. One is a linear function of the other, and they mean exactly the same thing. You can use either measure, student credit hours or FTE students, and you are communicating the same information. So really, the only difference between FTE students and student credit hours, other than the mathematical transformation, is the question, what do people understand better? Would it be easier to talk with a group of people about FTE students, or would it be easier to talk to people about student credit hours? Usually we talk about FTE students, full-time equivalent students, because the word student is somewhat reassuring when we're talking about the academic enterprise, and so it's an easier term to talk about in public. That's a very technical set of measures. FTE students and student credit hours are technical measures, and they are different than what people expect to talk about when we talk about enrollment. So there are additional measures of enrollments that we readily talk about. One is total student head count. So how many students do you actually have in your class, in your school, in your university? Student head count is an imprecise measure because students take different number of courses and different number of credits in those courses. So it's not a very exact number. We can also talk about enrollments by talking about the number of new students entering per year, or we can talk about the number of graduates in a year. Those are all valuable measures, and often when we talk about academic productivity, we talk about 4 measures. We talk about student credit hours, or full-time equivalent students. We talk about head count. We talk about number of entering students and the number of graduating students. And that gives us a nice picture of the past, the present, and the future. So the number of graduates is a measure of past productivity. A present measure of productivity is FTE students and head count. And a future measure of productivity, or a measure that points towards the future, is the number of students that enter into a program in a given year. Most commonly, When I talk about academic productivity, I try to talk about all four of those measures because they give a really holistic view of how many students are we impacting through a particular program or college or university. So I want to now give you some sample data, and I'll start by talking about student credit hours across 5 departments. And for each of those departments, we can talk about enrollments across 3 years. The reason I want to have you look at it this way, across 5 departments in 3 years, is because it is in the comparisons among numbers that we really find value with the data that I'm presenting. So I want you to take a look at the art department, the biology department, the business department, the chemistry department, and the education department. And I'm looking first at student credit hours, so SCH stands for student credit hours. And I want you to notice the different trends across the different departments, and I want you to notice the different trends across the different, within a given department across the 3 years. So you can see quickly that what's going on in business is quite different than what's going on in education. Let's look first just at 2017, 2018. You can see, first of all, that business is really big. It's the biggest department. It's got the most student credit hours generated by that department. Art, obviously, the smallest. Education's right kind of in the middle. And then if you look at the trends in business, you see an upward trend. So in 15-16, 2,369 credit hours were sold in business. That increased almost 1,500 credit hours in 2017-2018, a very nice upward trend in enrollment in the business department. If you look in education, it's exactly the opposite, or similar. It is an opposite pattern, different numbers but opposite pattern, where in 17-18 they shrunk by less than half of what they were in 2015-16. I actually saw that pattern in an education department in my previous institution, where the department was crashing, and the student credit hours sold demonstrated that crash or documented that crash. You can see that the patterns in art are similar to the pattern in education, but not as pronounced. So there is a decline in enrollment in art, not nearly as disturbing as the decline in enrollment in teacher education. And then you see that the patterns in biology and chemistry are a lot more stable. So business looking really good, art and education very concerning, biology and chemistry look pretty stable in their enrollments across those 3 years. This is typically how the data get presented. You're looking at multiple programs at one time, and you always try to look at multiple years because it is across years that you see the important trends in academic programs. The next step we could do is convert those student credit hours to FTE students. So again, I just took the student credit hours, I divided by 30 in this case for undergraduate enrollments to get FTE students. And you can see that business is serving about 127 students, education about 47. Biology is a fairly big department or has a fair number of student enrollments per year. But the patterns are exactly the same because student credit hours and FTE students are telling the same story, just with a mathematical variation. We can also look at head count, we can look at new students, and we can look at graduates. And when you look at all of those things together, if we were doing a deep dive into, say, the business department, you can see that the head count of majors is less than the FTE students. Now, what does that mean? Why would that be the case? Well, it's likely the case because you've got students who are minors in that department. You've got students who take classes in that department who aren't majors in the department. And therefore, that the difference in FTE students from the number of head count is a function of how attractive those courses are in that department to students outside that department. So that's telling us, does the department draw in interested students from other areas? When we look at the new student population, That's, again, pointing us towards the future, and you always want to see either a stable or an increasing number of new students. We always want to see that across all these measures. When we see a big decline in FTE students or credit hours sold, we would look at the graduates to help figure out, did they graduate a giant class? Was there some exit that occurred where there may have been a really big class that was just really interested in one program that left, and when those students graduated, it left a big hole in the department. That happens sometimes. So you try to explain trends in data by looking across all of these measures, not just any one measure. So I would say if there was one big point to make by looking at the sample data, it is to always do comparisons and never just look at one data point. You're always trying to understand one number in light of all the other numbers that are surrounding that one number. So this is a very typical kind of productivity grid that you might see in a productivity study. You have two different measures of current enrollments, FTE students and head count. You have a measure of what's coming, the new students, and you have a measure of what has been in the graduates. And they together try to tell you a story of what's going on in a department. And it's the story that you generate from the data that matters a lot. It's the story that you will reflect back to a program director or a department chair if you're a dean. And then you have them speak into the story based on the enrollment data, the productivity data. Now, we've talked first about measures of student enrollments. We need to also pay attention to how many faculty does it take to serve those students. And so we're going to quantify the number of faculty in a similar esoteric manner. It's not necessarily intuitive, but it's important that we quantify faculty. So we're going to look at measures of faculty load, and these are, again, quantitative measures. Faculty productivity is usually measured by something called load credit. At Bethel, it's called teaching equivalent units, or TEUs. The standard term that I've heard across most colleges and universities is load credit. Bethel's chosen a different term. It means exactly the same thing. Load credit or teaching equivalent units measure faculty workload. If we were in a factory or we were in business, we might talk about how many hours per week are devoted to a particular task. In academia, we talk about load credit. Load credit is usually measured by course credit. So the most intuitive measure of load credit is you get 3 load credits for teaching a 3-credit class, for example. Now that's often the case, but it's not always the case. There are challenges in assigning load credit to faculty. One of the challenges is, do you give full load credit for science faculty who teach lab sections? Lab sections don't always carry independent course credit. So at my previous institution, a 4-credit class was always 3 hours a week in lecture and 3 hours a week in a lab. Well, that's 6 hours of work in front of students for a faculty member. We did not give 6 hours of load credit for that course, nor did we give 4 hours of credit, even though it was a 4-credit class. So load credit didn't equal course credit, and that was a function of lab sections. So science faculty will wrangle about how much course credit they ought to get for lab sections. It's a standard problem in academia. When we have music faculty teaching studio courses, these are private lessons for students. Do you give full load credit for really a tutorial for one student? When that doesn't involve a lecture, it doesn't involve a lot of prep for the faculty member. Usually studio courses don't get full load credit. Tutorials don't get full load credit. Other private lessons like language lessons don't get full load credit. Other problems are especially related to administrative assignments within a department. How do you assign faculty load credit for being a department chair or for doing research? These are problems that are, again, esoteric to faculty. These are problems that faculty and administration wrangles about almost endlessly, and no one is ever fully satisfied. The main point here is that load credit is the unit of analysis when we talk about faculty productivity. It is a measure that is based on course credit loosely and gets modified in situations where course credit doesn't really apply adequately to defining what faculty do. Load credit is an economic unit. Because faculty get paid salaries, that salary can be thought of as being split across all the assignments that a faculty member has. And so, in a sense, every load credit for a faculty member is like a salary unit for a faculty member. It is important, therefore, if you're a dean, to pay close attention to how many load credits you give for various assignments, because every new load credit you give for an assignment is, in fact, salary that you're assigning to a task. And when there's turnover, if you don't have all the salary you need for a particular assignment, you've got to find new dollars for that. So faculty productivity is measured through load credit. Load credit is loosely based on course credit. It is an economic unit in higher education because it is assigning faculty to particular tasks, and you always pay those faculty for those tasks. And it's important to keep a close watch on how many load credits you have assigned to your faculty. Load credit is not intuitive to people and is therefore often converted to a second measure called full-time equivalent faculty, or FTE faculty. So load credit is convertible to FTE faculty in a similar way to student credit hours being converted to FTE students. The equation for converting load credit to FTE faculty is to take the amount of load credit that you've assigned to one faculty member or many faculty members, and you divide the total load credit you've assigned to people by the definition of a full-time faculty member. Another simple example, if a faculty member has been assigned 24 load credits for a year of assignments, so let's say they teach 3 4-credit courses in the fall, that's 12 load credits, and let's say they teach 3 4-credit courses in the spring, that's 12 load credits. You take the fall load credits, 12, and the spring load credits, 12. That's 24 load credits that they've taught for the year. And if your definition of a full-time faculty member is someone who teaches 24 load credits, then you take 24 divided by 24, and you've got 1 FTE faculty member. The concept is not necessarily intuitive, but it is a way to quantify what is a full-time teaching load or what does a full-time faculty member do. You define it in terms of load credit, and then you convert load credit to how many full-time faculty you have or you might need. Just like student credit hours being converted to FTE students, load credit being converted to FTE faculty is the two sides of the same coin thing again. One is a linear function of the other. FTE faculty is a linear function of load credit. We can either talk in public about how many load credits we've got, or we can talk in public about how many FTE faculty we've got. It's exactly the same conversation. The only question is, what will people understand better when you talk? Do they more intuitively understand FTE faculty, or do they more intuitively understand load credit? You figure that out from the audience that you're speaking to, and you adjust what you talk about accordingly. It's not a question of what you're measuring. They both measure the same thing. It's a question of what communicates better to your audience. So we can look at sample data here as well. And I didn't go through all the math of this, but I want to show you again for 5 departments: art, biology, business, chemistry, and education. I want to talk about trends in faculty across years. And I also want to talk about trends in faculty for the various kinds of assignments. So remember earlier I said that administrative assignments also carry load credit. And we can distinguish between all assignments that include administrative assignments and teaching assignments, and we can distinguish between teaching assignments only. So in the top category on the sample data page, you can see, first we look at full-time equivalent faculty for all assignments, administrative assignments, teaching assignments, everything that people get load credit for. And you can see the business faculty is FTE of 9 faculty, so 9 full-time equivalent faculty in the business department. And you can also look then again at the education department, where there are 16 full-time equivalent faculty in 2017-18. Now, right away, you should be thinking back to the student credit hours and how the student credit hours generated in education were pretty small relative to business. And here we see that the full-time equivalent faculty are much larger in teacher education than they are in business. And you can begin to see the power of this kind of analysis, because now you're saying, there really aren't a lot of students there, but there's a lot of faculty, so what's going on? This is a very precise way to quantify what's happening in a department, and it allows you to consistently look across years and across programs to do apples-to-apples comparison across time and across programs. Now, when you look at the difference between all the assignments and the teaching assignments, it is important to ask, why is there a difference? The size of the difference between FTE faculty for all assignments and FTE faculty for teaching assignments tells you how much administrative load is happening in a given department. So look again at teacher education. In teacher education, there are 16 full-time equivalent faculty for all assignments and only 12 full-time equivalent teaching faculty in teaching assignments. What that means is the difference between 16 and 12, or four full-time equivalent faculty, that difference says there are 4 whole faculty devoted to administrative stuff in teacher education. Compare that again to any other department, chemistry, business, art, or biology, and you see the differences between FTE faculty for all assignments and teaching assignments is much smaller. So in business, there are 9 FTE faculty in all assignments and 8.8 FTE faculty for teaching assignments. That means that in the business department, there's almost no administrative overhead. There's almost no administrative cost for faculty. It's an efficient department because there's very little administrative overhead, versus in teacher education, there's a lot of administrative overhead. And in my experience, at least, teacher education does have a lot of administrative overhead, maybe not this much, but it does have a lot. The other programs often do not have a lot of administrative overhead. But you do look for that, and that's why you divide up FTE faculty in categories, all assignments and teaching assignments. The other thing that is really helpful is to look at the FTE assignments for adjuncts. That tells you the degree to which a department is reliant on full-time versus part-time people. And you'll see that art has no part-time faculty. Chemistry has almost no part-time faculty. You see a weird blip in 2016, 2017 in chemistry where you've got almost a full-time person as an adjunct, and that should raise a question for you. What happened? Well, that pattern is very typical if you have a sabbatical in a department. So chemistry probably had a faculty member in 16-17 who was on a full-year sabbatical, and that faculty member had to be replaced by a part-time person, and that's what that pattern shows. But it's important to look at adjunct FTE to see if you're staffing too heavily with part-time people or too lightly with part-time people. This helps you understand cost structures in a department. The student enrollment data and the faculty data are usually put together into ratios to help you understand what's going on in a department. Ratios of student data to faculty data tell you a lot about a department, and the most intuitive ratio that we talk about is student-faculty ratio. In productivity studies, that is always the ratio of FTE students to FTE faculty members. So when we're talking about student-faculty ratio, we're not talking about head count to head count, so how many students to how many faculty. We're talking about a more precise metric, FTE students, compared to a more precise metric of FTE faculty. In the sample data, we take the FTE students in a department and the FTE faculty in a department, and we simply divide FTE students by FTE faculty, and that gives us student-faculty ratio. So you can see that chemistry department has a ratio of 19.7 FTE students to 1 faculty member, and you can see that in teacher education, there's a ratio of 3.9 students to 1 FTE faculty member. That just kind of leaps out at you when you look at the data, and that says probably you got a problem in the teacher ed department. You're overstaffed with full-time faculty. Now, in this case, I'm looking at FTE faculty and teaching assignments only, and that tells us how many students a typical faculty member is teaching in a given year. It's not a completely intuitive measure because it's FTEs, full-time equivalent students to full-time equivalent faculty, but it does communicate very clearly differences across departments, differences across time, and it can tell you where there's a lot of faculty pain. In the chemistry department, when you've got a ratio of 19.7 FTE students to 1 FTE faculty member, that's telling you that's a really heavy faculty load. And in teacher education, it's telling you just the opposite. You've got people who don't have enough assignments. They're not teaching enough students. So it's helpful data when looking at what's happening across departments or across time. So let's talk about why we do all this technical work. This is, as I say now for the third time, it's esoteric information, but it's really important for academic leaders, for deans and provosts to figure out what's happening. Student productivity data helps monitor trends of growth and shrinkage in student populations very precisely. Student-faculty ratio data help you evaluate the need for more or fewer faculty. So in teacher education, in the previous example, you probably need to let a faculty member go. You probably need to not hire any more faculty, or at the very least, you need to meet with the department chair and say, what's going on in your department? We saw this remarkable shrinkage of student credit hours. We see that the ratio of students to faculty members is very small and very concerning. Is there some problem in the department where we need to intervene? Intervention could be help grow students back, could be releasing faculty, it could be understanding the personality dynamics within a department, but the data help you drill into a problem in the department or something to celebrate in a department. If I were being asked to hire a new faculty member in a department, the first thing I would do would be to go look at the student-faculty data in a productivity study, and I would also look at the FTE adjuncts to see, do you really need a new full-time faculty member, or could you just hire an adjunct faculty member? FTE adjuncts is one of those important numbers as well, because it may be that a university can set a target for how many FTE adjunct faculty a department should have before they hire a full-time faculty member. Because adjuncts are usually much cheaper, they're usually not benefit-eligible people, they usually are paid a lower wage, it may be that you have to hit a particular threshold in a department for FTE adjuncts before you are even eligible to hire a new full-time faculty member. One of the reasons I've gone into such technical detail in this lecture is because I wanted you to know that there is a common way of doing calculations, but not everybody does the calculations exactly the same way. And if you're trying to do productivity studies where you compare faculty productivity or student credit hour productivity across universities, you need to make sure that the calculations are the same. Student credit hour calculations are probably pretty comparable, but once those student credit hours are converted to FTE students, they may no longer be comparable, because I might define a full-time student as 32 credits. You might define it as 30 credits. If we're talking about graduate students, we might define it as 18 credits or some other number. And so it's important to know that if you're doing all the calculations, you can make comparisons reasonably across programs and time. But if you're not doing all the calculations, you have to ask first, what's their method? Did they use the same equation I'm using? With IPEDS, they try to control that. So IPEDS data is the Integrated Post-Secondary Education Data System that the Department of Education, the federal DOE, requires every Title IV eligible college and university to report. So we do IPEDS reports all the time. There's all kinds of IPEDS data. You'll find FTE IPEDS data for students and for faculty. And IPEDS calculates a different way. They do not require common metrics across measures of budget dollars. And so this is just a caveat to say, be careful when comparing numbers across institutions. Faculty contact hours are comparable, but load credit for faculty is not comparable across institutions. Usually, FTE students is not comparable. FTE faculty is usually not comparable until you go back and make sure that people have used all the same calculations. All of this to say, if you're doing productivity studies across schools, it's kind of a mess. Let me recap. I started by saying we need to measure productivity. A measure of productivity is a measure of output of education, and we measure that with how many students we connect with. The precise way to do that is by looking at student credit hours or credit hours sold. That's the primary measure. You can transform that using a linear transformation to FTE students. But it's important to also look at head counts, new students, and graduates. You're kind of triangulating exactly what's going on with enrollment through that combination of measures. You also then can look at faculty workload and faculty productivity using load credit. FTE faculty is a linear transformation of load credit. Two different ways to talk about the same thing. You then can use measures of student credit hours or FTE students to measures of faculty work through load credit, and you can get some valuable ratios. We've explored just one valuable ratio, student-faculty ratio, but there are, a lot of options that we could look at if we wanted to go more in depth, and sometimes you'll run into those in the literature.